Section 5.5 is on solving polynomial equations. So here are two other little formulas you should learn for factoring situations, factoring polynomials. The first is the sum of two cubes. In other words, we have a cubed plus b cubed. So we're adding together two cubes, and that factors into a plus b times the quantity a squared minus ab plus b squared. The difference of two cubes, so again you have a cubed and you have b cubed, but this time you're subtracting. That factors into a minus b times the quantity a squared plus ab plus b squared. Notice kind of some similarities between these. With the sum of two cubes, it starts with an a plus b. With the difference of two cubes, it starts with an a minus b, so that kind of makes sense. They both have an a squared at the front, a b squared at the back, and an ab in the middle. But notice the sign in front of AB is the opposite of what it is. So the sum of two cubes starts with an a plus b, but it has a minus AB in the middle. The difference of two cubes starts with an a minus b, but it then has a plus AB in the middle. So you'll need to learn those two formulas. So let's try each one of these. So factor each polynomial, and what I'm recognizing is that x cubed minus 64 is actually a difference of two cubes, because 64 is equal to 4 to the third power. So I could say this is the same thing as x to the third power minus 4 to the third power, which means that a in my formula would be equal to x, and b in my formula would be equal to 4. So now we just plug it into the formula, which was a minus b times a squared plus ab plus b squared. And then let's plug in what we have. So that would be x minus 4 times x squared plus x times 4 plus 4 squared. Cleaning that up, x minus 4 times x squared plus 4x plus 16. And that's the factored form of x cubed minus 64. Let's take a look at example number 2 here. 54x to the fourth plus 250xy to the third. Well, the first thing I notice is I can take out a greatest common factor of x. Both of those terms have an x in it, and I can factor that out. But 54 is not a perfect cube, nor is 250. But I do know that both of them are divisible by 2. So when I divide 54 by 2, I get 27, which is a perfect cube. That's 3 cubed. When I divide 250 by 2, I get 125, and that's a perfect cube. 125 is 5 cubed. So I will factor a 2x out of both terms, and that leaves me with 27x cubed. That's a perfect cube, plus 125 y cubed, and that's a perfect cube. So looking at this is the same as saying, well, I'm just going to have my 2x hanging out there, okay, and then I have, this is 3x cubed, because 3x cubed is 27x cubed, plus 5y cubed. 5y is 125, and y cubed is y cubed. So in my formula, a is going to equal 3x, and b is going to equal 5y. So the formula, a plus b times a squared minus ab plus b squared. Plugging in what I have, I'll have 3x plus 5y, that's a and b, times 3x squared, because that's my a squared, minus a times b, plus my b squared. Maybe I should have put square brackets around that. There we go. And cleaning that up a little bit, don't forget I will have my 2x. I can't forget about my 2x that was out in front. and then 3x plus 5y. Then let's clean up what's inside the square brackets here. The quantity 3x squared is 9x squared. Negative 3x times 5y is a negative 15xy. And the quantity 5y squared is 25y squared. And that's my final answer. So here's an interesting chart from your textbook. It talks about some of the different factoring techniques that you can use. First rule of factoring in my book is always to look for a greatest common factor. And they give you an example, or kind of a general case here. They have to throw in a few numbers, but is there something that you can factor out of each term? If you have two terms, always consider it could be a difference of two squares, so something like a squared minus b squared. Is it the sum of two cubes, a cubed plus b cubed? Or is it the difference of two cubes? That would be a cubed minus b cubed, in which case you have these formulas here. If there are three terms, is it a perfect square trinomial? Does it factor into something like a plus b quantity squared or a minus b quantity squared? General trinomials, this is a very confusing formula. But just remember, a general trinomial is in the form ax squared plus bx plus c. If a is 1, you're looking for two numbers that multiply to c and add to b. If a is greater than 1, then you're looking for two numbers that multiply to whatever a times c is and add to b, and then you'll need to use grouping from there. Watch some of my other videos that I have on my Algebra 1 YouTube channel. If you have 4 or more terms, you should always try to look for grouping. After you've taken out a greatest common factor, look for grouping, and we'll go through that in the next example. I kind of like grouping. It's one of my favorite ways to do factoring. So, next set of examples says factor each polynomial. And I have, oh my gosh, 30ax minus 24bx plus 6cx minus 5ay squared plus 4by squared minus cy squared. Well, first of all, I've got 6 terms, so the first couple ones aren't going to work. I don't see any greatest common factors in all 6 of those terms, but I do see that, let's see, I've got x's in all my first 3 terms, and I've got a y squared in all of those terms. This is going to be a perfect candidate for grouping. I'm going to group the first 3. I'm going to group the last 3. Grab that minus, put a plus up there. And now, out of each set of pink parentheses, I'm going to take out a greatest common factor. For the first one, I think it's going to be a 6 and an x. So 6x, and that will leave me with 5a minus 6b plus c. Okay? Out of my second set of pink parentheses, since it starts with a minus, I'm going to take a negative something out, and I think the only thing I can take out is a negative y squared. Sorry, negative y squared. That's going to leave me with 5a. Whoops, I made a mistake back here. That is not a 6, that should be a 4. Sorry about that. 5a plus 4b. Oh, wait a minute, minus 4b, since I'm taking out a negative. That's going to be a minus 4b plus c. And when you're factoring by grouping, remember you should have exactly the same stuff in the parentheses. So I can put my 2 extra terms out front. I like to call them my lonely boys together in parentheses. And then my common factor in both terms. And nothing else can be taken out. This isn't a difference of 2 squares. So that's my final answer. Let's take a look at another example here. Wow, x to the 5th plus 4x to the 4th plus 4x to the 3rd plus x squared y cubed plus 4xy cubed plus 4y cubed. Okay, again 6 terms. Again, I'm seeing a bunch of x's here. I have x's here, but I also have y cubes in those. So I'm going to go grouping. Group my first 3, group my last 3, and start looking for common factors. Common factor in this, I think, is going to be an x cubed. So that'll leave me with x squared plus 4x plus 4. Ooh, I think that can be factored. I think it can. Yeah, that can be factored. And then out of the last one here, I can take out a y cubed. And that's going to leave me with x squared plus 4x plus 4. And again, I have the same stuff in the parentheses. So one factor is going to be x cubed plus y cubed. Taking those two out front. My other factor is going to be x squared plus 4x plus 4. And I'm not done, because this is actually the sum of two cubes, and I believe this is a perfect square trinomial. So factoring my sum of two cubes, I'm going to have an x plus y. And this one's kind of easy because they don't have any coefficients, so you can just kind of think in terms of a and b. And an x squared minus xy plus y squared. And for my difference of squares, that's going to be an x plus 2 quantity squared. And that is factored. That was a lot of stuff in that one. So once you've kind of done your grouping thing, you need to look at what your two factors are, and can those be broken down further. Completely factored means it's broken down as much as possible. Quadratic form. Quadratic form is writing an expression in basically quadratic form. Something like, remember when we talked about quadratic equations and quadratic functions, they were in the form ax squared plus bx plus c. But a quadratic form is an expression that can be written as au squared plus bu plus c, where u is an expression in x. So in other words, this u is going to equal something x, like x squared or x cubed, something like that. Let me show you what I mean in a couple examples here. So we have x to the fourth plus 12x squared minus 8. So what I'm going to do is I'm going to say let u equal x squared. Okay? Then I can write this as, since u is x squared, this is really going to be u squared. Because if u is x squared, and x squared squared is going to give me x to the fourth, plus 12u, since u is x squared, minus 8, or what they're really looking for is x squared squared plus 12, and I'm going to put that x squared in parentheses, minus 8. So in other words, instead of thinking of this as x to the fourth, I'm going to think of it as x squared squared. Instead of thinking of this as, like actually an x squared, which we would usually start with, that's just a term unto itself. We're going to use this in the next set of problems to actually solve some equations. Okay, second example here, and that's our final answer. That's kind of what we're looking for right there. Next set of problems, next problem we have 9x to the 8th minus 21x to the 4th plus 12. One of the key things is if you can write it in quadratic form if you've got kind of this exponent is twice as much as this one. Notice that in regular quadratic form we would have an ax squared and a bx, where the x squared is kind of twice the x. So in this case, I need to have x squared. I'm going to let u equal x to the fourth. Okay, so I can write this as 9u squared minus 21u plus 12, or now substituting in x to the fourth, 9 x to the fourth squared minus 21 x to the fourth plus 12. And that would be written in quadratic form because it's basically 9 times something squared minus 21 times the same thing plus 12. Now we're going to use that to help us solve some equations and use our quadratic factoring techniques. But notice this is not a quadratic equation since it starts with x to the fourth. So I'm going to start by rewriting it in quadratic form. Since this is an x to the fourth and an x squared, I'm going to let u equal x squared. And now I'm going to write this as 4u squared minus 8u plus 3 equals 0. And now I'll factor this to save us a little bit of time. I already did that. 2u minus 1 times 2u minus 3 equals 0. Now don't get thrown off by the u. Just think of it as x. And when you're going to factor this, Remember, you're going to look for two numbers that multiply to 12 and add to -8 and do the whole factoring by grouping thing. To save us some time, I just went ahead and did that. So this is going to give me 2u minus 1 equals 0, 2u minus 3 equals 0, or 2u equals 1, u equals 1/2, 2u equals 3, or u equals 3/2. Now, what I'm looking for is what x equals, not what u equals. So now's the time to substitute x squared back into here for u. So if x squared equals 1/2 and x squared equals 3/2, now I'm kind of back in a little more familiar land. I know what to do with this. Take the square root of both sides. So x is equal to the positive or negative square root of 1/2. X is equal to the positive or negative square root of 3/2. And then cleaning up those radicals, x is equal to plus or minus square root of 2/2. And x is equal to plus or minus the square root of 6/2. And those are my two answers. Notice that this problem started with an x to the 4th, and I actually have 4 answers. There's the positive and negative square root of 2/2, and the positive and negative square root of 6/2. 4 possible answers. If I were to graph the related function here, it would cross the x-axis in those 4 places. So, since this is an x to the 4th, the highest number of possible answers I can have is 4. Okay, here's another one with x to the 4th. So let's say, let u equal x squared, and I'm going to write this as u squared plus u minus 90 equals 0. Factoring that, I will get u plus 10 times u minus 9 equals 0, which means u plus 10 equals 0, or u equals a negative 10, u minus 9 equals 0, or u equals 9. Now it's time to substitute back in x squared for u. So x squared equals negative 10, x squared equals 9. Taking the square root of both sides, I have x equals plus or minus the square root of negative 10, which means x equals the positive or negative of I times the square root of 10, and square root of 10 can't be simplified. And x equals, this one's easy, positive or negative 3, because the square root of 9 is 3. So again, I started with a problem that was x to the 4th, and I ended up with 4 answers. 2 of them real, 2 of them imaginary. So if I were to graph this, it would only cross the x-axis in 2 points, because remember, with imaginary numbers, it doesn't cross, or complex solutions, it doesn't cross the x-axis. Example number 3, x cubed plus 216 equals 0. So this is going to be a sum of 2 cubes, where my a is x and my b is actually 6, because 6 to the 3rd power is 216. This is going to factor into x plus 6 times x squared minus 6x plus 36 equals 0. So that means x plus 6 equals 0, or x equals a negative 6. There's one of my solutions. And x squared minus 6x plus 36 equals 0. That can't be factored, so I need to use the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. That simplifies into x equals 6 plus or minus the square root of negative 108 over 2, and that will simplify into 6 plus or minus 6i square root of 3 over 2. And then simplifying that a little bit further, doing a little canceling, x equals 3 plus or minus 3i square root of 3. So in this case, I have a cubic, so the most number of answers it can have is 3, and it does have 3 answers. However, only one of them is real. The graph of the related function here would cross the x-axis at -6, and here we have 2 complex roots, which means it does not cross the x-axis at those spots. And our last example here, 4x to the 4th minus 5x squared minus 6 equals 0. Since I have an x to the 4th and an x squared, I need to do a u substitution. Let u equal x squared. Rewrite this as 4u squared minus 5u minus 6. And factor that. I'll save a little bit of time here and go ahead and factor that for us. That's 4u plus 3 times u minus 2. So 4u plus 3 equals 0. U minus 2, u minus 2 equals 0. So u is equal to a -3/4, and u is equal to a +2. Substituting back in x squared equals -3/4. X squared equals 2. So x is equal to the positive or negative square root of -3/4. Cleaning that up, getting rid of the negative in there, we have plus or minus I square root of 3 over 2, and taking the square root of both sides here, x equals plus or minus the square root of 2. So here are 2 complex solutions. Here are 2 real but irrational solutions. So solving polynomial equations, sometimes you'll need to use something like a sum or difference of cubes like we did here. You might need to write it in quadratic form and substitute u for x squared. Sometimes you'll get real solutions, real rational solutions, as we did here with -6. Sometimes you'll get real irrational solutions, as we did here with positive and negative square root of 2, and sometimes you get complex solutions.